Fractions are a fundamental part of elementary school mathematics, notably in grades 3 through 5. What students learn about fractions in these grades sets them up for fractions they will encounter in future math classes, science classes, and real-world situations. As elementary school teachers, we need to ensure that students have a strong conceptual understanding of fractions by the time they are ready to begin middle school. How do we do this? Let's consider how to break up the topic of fractions into different parts so that we can get our whole, students strengthening their conceptual understanding of fractions. I'm going to be discussing how we can reimagine fractions so that we don't need to change what we teach, but rather how we teach it. This is inspired by my reading of the book Sparks of Genius. First, let's review the big ideas for third, fourth, and fifth grade fractions. These are the big ideas that fall under the Common Core domain of numbers and operations fractions. In third grade, students will develop understanding of fractions as numbers. In fourth grade, students will extend understanding of fraction equivalence and ordering, build fractions from unit fractions, and understand decimal notation for fractions and compare decimal fractions. In fifth grade, students will use equivalent fractions as a strategy to add and subtract fractions, and they will apply and extend previous understandings of multiplication and division. With these big ideas in mind, let's start with what we have in the classroom, our Go Math curriculum. While the math curriculum is not the end-all be-all, it is a good starting point. We need to know what standards are covered, how much do the standards spiral, and how the standards are presented. We then need to consider what's missing from the curriculum. We also need to consider how we can take what is in the curriculum and find tools to deepen the concepts. Here are the different thinking tools we can integrate into math lessons to change how we teach fractions. These thinking tools are play, perceiving, patterning, abstracting, modeling, and embodied thinking, and they're featured in the book Sparks of Genius. These different thinking tools will represent different parts we can integrate to foster the whole, or in other words, to foster our goal of strengthening student conceptual understanding of fractions. So we want to change how we teach fractions, but why do we want to do this? As the Root Bernstein state in their book, Sparks of Genius, the more ways students can imagine an idea, the better their chances of insight. With this, I will go over several fraction concepts as shown on the slide here and provide suggestions on how to integrate thinking tools when teaching these concepts. As a reminder, by integrating these thinking tools, the purpose is to provide students an opportunity to reimagine fractions in ways that strengthen their conceptual understanding. For the tools I discuss, a more thorough description of each one is posted in the links below this video. So first, let's think about introductory lessons for fractions. Here I'm thinking about an activity that 4th or 5th graders would do before they formally start the math chapters on fractions. Basically, these students would have prior knowledge about fraction fundamentals from their previous grade, whether that was from 3rd grade last year or 4th grade last year. One activity for this is having students design a fraction playground. They would divide up a 10 by 10 grid and they get to create playground sections based on their interests. This incorporates the thinking tool of play, so it's a part of our whole. It presents a low-stakes, high-interest activity where students need to recall how to form fractions to divide up their playground. This play activity points out how fractions are seen everywhere, even on the school playground. Now this activity is reintroducing what a numerator and denominator is. Instead of just drawing a pizza on the board to model 1/8, I want my students to perceive fractions differently, which is another part of our whole. We'd form a circle and we'd generate various fractions based on criteria about their shirts. Students are now an active part of the learning. They're not just passively looking at the pizza on the board. They need to be actively listening to figure out the fractions. Let's move on to another fraction concept, understanding that fractions represent parts of a whole. This is derived from a 3rd grade Common Core standard. This concept needs to be understood in order to set students up for success in understanding future fraction concepts. A way to help students conceptualize parts of a whole is through abstraction, another thinking tool. Abstraction has us break apart a concept, in this case fractions, to focus on one element, the element being parts of a whole. By abstracting parts of a whole in different ways, students receive different ways to interpret what part of a whole means. For example, the top image shows a photograph of patterns on a building. The patterns form different parts of a whole, as you can generate different fractions depending on the criteria. If I look under the pattern under the left window, that would be my whole. Part of it would be that 2/4 of the triangles are gray. So this photo can lead to discussion on other geometric patterns that are incorporated into building design. Another example of abstraction is the musical composition. The rhythm shows a whole note representing the whole. It also shows parts of the whole because it shows several music note subdivisions of the whole. Students could clap along and listen to this rhythm. This auditory and kinesthetic learning helps students hear how the music represents parts of a whole, which in turn represents fractions. Now let's look at the fraction concept of fraction models. Two-dimensional models often accompany fraction math lessons. If students use a three-dimensional model, it is typically in the form of a manipulative like fraction circles or fraction strips. We want to go further with these 3D models as we consider the thinking tool of modeling, another part of our whole. To help bring fractions to life, teachers should think of all sorts of real-life tangible models that support the fraction models of set model, area model, and linear model. Here are 3 examples to get you thinking that represent a set model, an area model, and a linear model. Moving on, we have the fraction concept of equivalent fractions. This concept comes up in all upper elementary school math classes. A big part of this concept is using patterns, which is our next thinking tool. Teachers should be explicit in guiding students to seeing such patterns. For instance, equivalent fractions name the same amount, because what you do to the numerator, you must do to the denominator. Students typically visualize these equivalent fraction patterns with fraction strips, but you could also even reimagine the fraction strips by having students form equivalent fractions based on their shirt designs. Finally, here is our last math concept, performing operations with fractions. This concept is a part of 4th and 5th grade math. Patterns can also be used within this concept. For instance, if students understand the pattern of inverse operations undoing one another, this gives them a valuable way of finding solution pathways in word problems and in checking their work. Going off this, teaching students how to divide fractions provides an opportunity to explore the pattern behind keep, change, flip. Understanding the pattern between multiplication and division helps students easily set up and solve fraction division problems. Looking at addition of fractions now, one last thinking tool can be used, and that is embodied thinking. Students mentally use fractions to break up their day, even if they don't realize it. Teachers should explicitly connect this mental breakup of fractions to how it relates to fraction addition. One example would be the day schedule. You could discuss how each subject time slot represents a part and the whole is the entire school day. Another activity with this tool would be by having students segment their bus route to school. With both these activities, students would generate fractions to add up to get their whole, whether that's the whole school day or a complete bus trip. Both of these activities go to show how students embody the concept of fractions as they mentally fraction off their day. The 6 thinking tools covered here are ways that we can reimagine how we teach fractions. When trying this in your classroom, think about this. What is the fraction concept? What are my students' funds of knowledge? Why is this concept important right now and in their future? And what could be a thinking tool to use? Remember, we want to integrate these tools, the parts, to reach our whole, the goal of strengthening student conceptual understanding of fractions.